Hi ladies, today we have lesson 10.1, trigonometric identities. Our learning targets are that you can use trigonometric identities to find trigonometric values, and you can use trigonometric identities to simplify expressions. So our only new vocabulary word here is a trig identity, which is an equation involving trig functions that is true for all values for which every expression in the equation is defined. So an identity is when you get one side of the equation to equal the other side. It's like looking in the mirror, looking at your identity. So our first key concept slide here is your basic trig functions, or identities, I should say. And this is going to be your life-saving slide. I don't know if you want to take a picture of it and put it somewhere, but these are all of your identities. So you have your quotient identities, meaning you're dividing. You have your reciprocal identities, meaning sine, cosine, tangent, cosecant, secant, cotangent. You have your Pythagorean identities based off Pythagorean theorem. You have your cofunction identities, and you have your negative angle identities. So what you're going to do is use these identities to rewrite things or to solve to make equations equal to one another. So for the first one, it says find the exact value of cosine of theta if sine of theta is equal to 1/4 and 90 degrees is less than theta, which is less than 180. So what this is telling you is what quadrant you're in. So if you are between 90 and 180, you know that you are in quadrant 2. And you know in quadrant 2 that you have a cosine value that is negative and a sine value that is positive. So we can use one of these functions, and if we look back up here, we can use this lovely Pythagorean identity. Cosine squared of theta plus sine squared of theta equals 1. So we are going to say cosine squared of theta plus sine squared of theta equals 1. So if we know sine of theta is 1/4, we know that cosine squared of theta plus 1/4 squared equals 1. Excuse me, is it minus? No, yeah, minus. So we will say that cosine squared of theta is equal to, not equal, plus 1/16 is equal to 1. Subtract 1/16, and you will get cosine squared of theta is equal to 15/16. And then you want to take the square root of each side, and we are left with cosine of theta is equal to the square root of 15 over 4. I should say plus or minus the square root of 15. And we know that since cosine needs to be negative, that our final answer is cosine of theta equals negative root 15 over 4. So then B says find the exact value of cosecant of theta if cotangent of theta is equal to negative 3/5 and 270 degrees is less than theta, which is less than 360. So this means that we are in quadrant 4, which means that we have a positive cosine and a negative sine. So cosecant. So that would mean that we have a positive secant and a negative cosecant. So we look back up here for cosecant and tangent. And you can see that cosecant and cotangent you have right here is a Pythagorean identity. Cotangent of theta plus 1. So we have cotangent squared of theta plus 1 is equal to cosecant squared of theta. So we know that tangent of theta is negative 3/5. So we would have negative 3/5 squared plus 1 equals cosecant squared. So we get 9/25 plus 1 equals cosecant squared. And that would give us 34/25 equals cosecant squared. We want to take the square root of each side. And we get the square root of 34 over 5, plus or minus, equals cosecant of theta. And since we need cosecant to be negative, we know that we will have cosecant of theta equals negative root 34 over 5. And that is our final answer. So now I'd like you to pause and try 1A and 1B just as we did above. Okay, our next example here says simplify an expression. So it's telling you that it's often easiest to write all expressions in terms of sine and or cosine, just because that makes it simpler to solve. So we have simplify sine of theta, cosecant of theta over cotangent of theta. So I want to rewrite these in terms of sine and cosine. So I know that the sine of theta times the cosecant of theta all over cotangent of theta is equal to the sine of theta times cosecant is 1 over the sine of theta, and cotangent is 1 over tangent of theta. So if I am to simplify this, my sines will cancel out from cross-canceling, cross-reducing. So I'm left with 1 over the tangent of theta. This is equal to 1 times the tangent of theta over 1, which is equal to the tangent of theta. And that is how you simplify a trig expression. So now I'd like you to pause and try 2A and 2B using your chart from up here to simplify these expressions. Okay, next we have a real world example. It says simplify and use an expression. So it's referring to the beginning of the lesson. It had a problem that says the amount of light that a source provides to a surface is called the illuminance. The illuminance E in foot candles on a surface is related to the distance R in feet from the light source. The formula secant of theta equals I over ER squared, where I is the intensity of the light source measured in candles, and theta is the angle between the light beam and a line perpendicular to the surface, can be used in situations in which lighting is important, as in photography. So the first thing it wants us to do here is to solve the formula in terms of E. So we want to isolate the E. So first we have the secant of theta is equal to I over ER squared. So the first step in isolating this E is to multiply by the whole thing of ER squared. We want to get it out of the denominator. So then we are left with ER squared times the secant of theta equals I, because those will cancel themselves out. Then what we want to do is rewrite secant of theta in terms of cosine, because remember we want things in terms of sine and cosine. So we will have ER squared times 1 over cosine of theta equals I. Then we will divide by, well, we will, let's just put this all over. ER squared over cosine of theta equals I. Now we want to multiply by cosine of theta, multiply by cosine of theta, so that that moves. We are left with ER squared equals I cosine of theta. Then to isolate the E, we will divide by R squared, and we get E equals I cosine of theta over R squared. And that is our final answer for how to isolate the E. Section B, part B, says, is the equation in part A equivalent to R squared equals I tangent of theta, cosine of theta, E, and explain. So what we want to do is we want to take the original equation and we want to see if we can isolate the E in this to see if they are the same. So we have R squared equals I tangent of theta cosine of theta over E. So we want to get rid of our E, so we're going to multiply each side. So we have ER squared equals I tangent of theta cosine of theta. Then we want to divide by the R squared. So we have E equals I tangent of theta cosine of theta over R squared. Now we want to simplify that tangent and that cosine. So we know that tangent is equal to sine over cosine times cosine. We'll just put it over 1, all over R squared. So we can see that this will cancel out to be simplified to E equals I sine of theta over R squared. And we can see that these are not equivalent because one of them is I cosine of theta and one is I sine of theta. So no, not equivalent. So now I'd like you to pause and try number 3, where you are rewriting cotangent squared of theta minus tangent squared of theta in terms of sine of theta.